Good afternoon, everyone. My name is Amy Lambert, and I'm KCI's Director of Corporate Communications. I'd like to welcome you to this KCI webinar on pump station audits. Today's presentation will focus on pump station audits. This webinar will cover protocols and procedures, the benefits of regular assessments, and how to incorporate findings into an asset management program. Our presenters today are Marco Menendez and Jason McClafferty. Marco is a senior project manager and water wastewater practice leader with more than 26 years of experience. Jason has more than 10 years of experience, including numerous pump station audits. Mehmet Bose and I will be your moderators. Mehmet is a vice president and environmental discipline manager here at KCI. Keep in mind that this webinar is meant to be an interactive presentation. You may use the Q&A feature below to ask a question at any time, and we will do our best to provide responses as we go. We will also have a brief Q&A session at the end. With that, I'd like to turn it over to Marco.
Hello, everybody. I'm very happy to be joining you today to talk about pump station audits. And we're going to focus on wastewater pump stations. But what we really hope to get across today are the importance of these audits, why you might want to consider them if you work for a utility, and how they're conducted to get you the best information that you need to move forward. With wastewater systems, what's the problem? The American Society of Civil Engineers has given the infrastructure report card grade of D+ for wastewater systems. These report cards are developed by ASCE every 4 years, focused on 16 different types of infrastructure, and wastewater is one of those types of infrastructure. What the D+ grade means is that our wastewater systems are in mostly poor condition, they're approaching the end of useful life, and there's a strong risk of failure. That's not a good situation. As you can see with the picture on the right, that's what a sanitary sewer overflow might look like. And obviously we've gotten used to things being relatively clean in our streets and in the environment. And when we come across these surprises like this, it can be shocking. So what are the reasons why we have the D+ grade in our wastewater systems? Well, age is one reason. Some systems are 30, 40, even approaching or even going over 100 years old. Neglect is a reason. Sometimes these systems there's not enough focus put on them, not enough focus put on the repair and rehab of the infrastructure. Poor condition can be an issue. Sometimes condition problems may not be caused by age alone. Funding challenges is a big issue. There simply may not be enough available through rates and other funding mechanisms to meet all of the needs that are out there. So when you look at the wastewater systems, obviously they're composed of different types of things. There's gravity sewer piping, there's wastewater treatment plants, pumping systems. I would argue that some of the more recent funds have been spent on gravity sewer piping and wastewater treatment plants. With gravity sewer piping, there's been lots of I&I studies, which are infiltration and inflow studies, and subsequent rehab associated with those systems, such as lining of pipes. Wastewater treatment plants, obviously a lot of studies, design and construction of rehab plants. But where do pump stations stand? In many ways, these pump stations are out of sight, out of mind. Sometimes these are in remote locations, and there's just not simply as much attention paid to them. So what do we do about this? Focusing on what the problems are, I think a lot of us have heard of the triple bottom line principle. And basically what this means is that these different aspects, public, environment, and cost, really need to all be considered when we're looking at our wastewater systems. As far as the public is concerned, You could simply have a nuisance, such as an odor, that's caused by your pump stations. Or it could actually be a public health issue. As far as the environment is concerned, everybody's aware of sanitary sewer overflows and the effect on the environment that those can have. As far as costs, capital and O&M expenses play a role. So focusing a little more on the environmental problems, EPA estimates that up to 75,000 sanitary sewer overflows occur every year in our country. That's a lot of wastewater that's being spilled. And there are many reasons for these sanitary sewer overflows. You might have a flood at your pump station site. You might have a force main failure. And it's important to recognize that force mains are part of your pumping system. It's not just your pumps and your pump station site. You really have to look at your force main as well. Flushables are an issue. I think everybody's aware of the problems that flushable wipes can pose on your sewer system. They can cause pump problems. They can cause problems in your force main and get hung up on different things. You could have pump or SCADA failure. That could cause a sanitary sewer overflow. So there's lots of different issues that could cause these SSOs. As far as public safety and nuisance is concerned, SSOs in general can be a public health and nuisance issue. It could cause unsightly appearances of wastewater on the ground that people could complain about. It could obviously cause a public health issue if people come into contact with the wastewater. But as far as the odors are concerned, sometimes that's a public health issue. Sometimes it's just a nuisance. It's important to understand that high levels of hydrogen sulfide odor, which is H2S, can really be dangerous, especially for your O&M staff. Public safety at pump station sites is an issue. Is the site secure? Do you have fencing? For your O&M staff, is there appropriate fall protection and arc flash protection? So these are things that need to be considered when you're looking at public safety and nuisance. Costs. Cost is a big issue. With new construction, a lot of that is apparent and how that's funded. Sometimes that's funded through developers. But what about rehab and replacement? Is that accounted for in your rates? It could be rehab or replacement of structures, equipment, piping. That stuff costs a lot of money. On the O&M side, there's obviously labor that occurs with the utility staff. But that utility staff obviously has to spend a lot more time on the maintenance headache issues that occur in the system. Power consumption. That's a big issue with pump stations. They're constantly needing power to operate the pumps. But what happens with poor pump performance? How does that affect the overall power consumption and the costs associated with that? So not only do we have to look at the triple bottom line at the pump station sites themselves, but with these pumping systems, we really have to look downstream as well. With the odor and corrosion that I've spoken about already, what's happening downstream? When that wastewater is pushed through the force main, what kind of effect is that having on your gravity sewer system, on your wastewater treatment plant? The picture you see to the right is from a project where there was a force main discharge just upstream of this manhole. So you can see the effects that corrosion had on that manhole. Flows. What's happening downstream with your flows? Pump stations could be sized too high. I think a lot of us know that state requirements as far as the amount of flows that go through pump stations are relatively conservative. And is that your pumping system size too high for the wastewater that's coming to it? That could be a problem if you're experiencing wet weather. And what happens downstream you could cause SSOs if your pumps are pumping too high. So there's lots of different problems that you can find that are associated with your pump station, your wastewater pumping systems. And again, it's important to understand that force mains are really a part of that overall system. So finding the problems, what do? Pump station audits are a great way to find the problems and really look at figuring out what to do about those problems so that you can manage those assets effectively. It really should start with the operator interview. These operators have some historical knowledge that engineers simply aren't going to have. Evaluation of pump performance. The pumps are why you have the pump station in the first place. It's a big deal to make sure that those pumps are performing properly. But it's also a big deal to look at your force main and make sure that the force main is working as intended. Condition assessment. There's different materials at your pump station sites, between pipes and structures and panel boxes and so forth. What's the overall condition of those materials? Site evaluation. When you go out to the site, can it be easily accessed? Are there other site issues? Flooding that might occur out on site. Electrical and instrumentation. It's important to not forget about electrical and instrumentation. With electrical, are arc flash considerations considered? With instrumentation, are your floats working properly? Other systems with instrumentation, are they working properly? And then with odor and safety assessment, it's important to make sure that O&M staff are safe, that the public health is taken into account, and that any nuisances are also taken into account. So at this time, I'd like to have a poll question. So the poll question is this: what is the typical percentage of O&M costs attributable to power at pump stations? And I'll give you a few moments for people to answer. O&M costs could be labor costs, it could be power. Sometimes you have maintenance headaches, with O&M, so your labor could be a little higher, in some systems. Okay, so thank you for those answers. Really appreciate that. So some of the results, it's been pretty even actually, between 55 and 65%, and then the first three answers, it's pretty even. Almost a third of people answered for each of those. But what EPA actually estimates is that power consumption is attributable to 85 to 95% of costs at pump stations. And it's recognized that that might not be the situation at every utility, and this is an EPA estimate. But one thing that it does highlight is that the power consumption at these pump stations, it's an important aspect of these pump station audits and things that need to be considered. Is that pump or those pumps, are they operating as they're intended? If they're not, that could mean that the cost of power is simply higher. All right. So now I'm going to take a deeper dive into pump station audits. And, some utilities have performed these audits, many have not, but we're going to try to relay the importance of these pump station audits and why we think it should be a part of your overall wastewater system assessment. So it really starts with O&M staff interviews. And this is really critical to the pump station audits. And the reason it's critical is simply because there are many issues that engineers just can't see. The O&M staff that are there, they might have that knowledge that the engineer simply doesn't have. In addition, some of these O&M folks have been working for the utility for many years, and they have historical knowledge that really needs to be grabbed. And some of these individuals are near retirement, and that's another issue, another topic. But it's very important to pick their brain and understand the problems that they consistently have to deal with. You can see some of the questions there, but the importance is to ask specific questions, because we can go out to sites with the O&M staff and so forth, but if we don't ask these specific questions, they may not bring them up. To them, these issues just may be day-to-day issues that they have to deal with. And maybe it's not a big deal to them, it's just part of their job. It's up to us to ask these specific questions, such as, do you have to replace pumps often at certain pump stations? What are the biggest headaches that you have to deal with at your pump stations? What kind of Band-Aid fixes have you made at your pump stations? So all of these are important to ask, and it's important to spend that time up front before the site visit is made. So once we get that O&M staff interview done, then it's important to go out to the site and start with the pump performance analysis. This starts with the drawdown test. And with the drawdown test, what we're doing is we have to measure the inflow and the pumped flow. There's various ways that this can be done. You can have an expensive audit performed, where you have lots of instruments being used, or you can simply measure the flow coming in. You could use things such as a tape measure or a level instrument, but it's important to get that inflow coming in addition to the pumped flow. Use the geometry of the wet well to determine what that flow is coming in and going out of the pump station wet well. It's also important to recognize that pressure gauges are a really important part of the pump performance analysis. There are many pump stations out there that don't have pressure gauges. What would typically be recommended prior to the pump station audit is that pressure gauges be installed on the force mains, typically in the valve vaults. The reason those pressure gauges are so important is it helps us determine the true pressure that the pumps are operating against. That true pressure is, in essence, the total dynamic head in the system. And that total dynamic head is very important for us to understand along with the flow, so that we can see whether or not the pump is operating on its curve. You can see the pump curve there to the right in red and the operating point circled. Well, that operating point may not be where that pump is operating. Maybe it's operating to the right of that operating point, which means it's operating at a higher flow than originally intended. Maybe it's operating to the left of that operating point, which may mean that you have obstructions in your force main. Maybe it's not operating on the pump curve at all, and that dash line that you see there with the system head or system curve, maybe there's been something wrong with that that system curve, things are, you may have a combination of system problems and pump problems. But understanding where you're operating with the flow and the head is important, so that you can truly analyze, is this a pump problem? Is this a force main problem? Or is it both? So as far as power consumption is concerned, and I mentioned that's an issue, of course. What are the different factors that are associated with power consumption? First of all, just the hydraulic horsepower. It's important to take that into consideration. And what that is it takes a certain amount of energy to move a certain weight of water at a certain flow rate against a certain pressure. But when you're looking at power consumption, you also have to take into account that there's a pump efficiency that has to be included in addition to a motor efficiency. And typically what happens with these systems, if you're looking at power consumption, the real varying factors tend to be flow, total head, and pump efficiency. These are all things that are seen on the typical manufacturer's pumping curves. So again, is the pump operating where it's supposed to be at its operating point on the pump curve? If it's not, it might be that you have a much lower pump efficiency than you originally intended. And if that's the case, then your power consumption might be higher than you originally thought. So it's really important to look at what we call the wire to water efficiency of your pumps. So at this time, I'd like to take a closer look at pump curves. And what do these really mean? What's going on here? You can see on the left, this particular pump curve that you see in red is a 425 gallon per minute at 75 total dynamic head situation. And the way that we determine that is with the blue curve, that's what the system pressure is at that flow. But what happens if things change? What happens if we get obstructions in our force main? What happens if valves are partially closed? That system may be operating completely differently than originally intended. If you look to the curve on the right, that's the same pump curve, but you can see the system has changed because of some sort of issue in the force main system. What you can also see there in those red curves where you see 80, 70, 60, and so forth, that's pump efficiency. So the original pump curve and system curve that you see on the left, that pump efficiency is around 80%. That's a pretty good pump efficiency. But you can see with the curves on the right, that efficiency can drop pretty quickly. For this particular pump with just an extra 5 feet of total dynamic head, the flow is reduced by 115 gallons per minute. In addition, you can see that the pump efficiency has dropped. We thought it was going to be operating at 80% efficiency, but now with just 5 feet of extra head, it's operating at 60% efficiency. Think about all of the times that this pump is operating at that lower efficiency and the extra power consumption and associated cost of that power. This can pose some problems, of course. Not only does you see the drop in efficiency that might lead to higher power costs, but with the lower flows, you may have some serious problems with that. That could cause sanitary sewer overflows because the pump is simply not delivering what it's supposed to. So let's look at what can cause this extra head to be introduced on pumps. First, I think everyone's aware that wastewater has solids in it, and those solids can settle. 2 feet per second is the typical scouring velocity that's required in force main systems. It may be that initially the flow is such that you have that 2 feet per second of velocity in your line. Over time, things may change. You might have more head loss introduced, and that velocity could drop to less than 2 feet per second. Solid settling can be a concern in this case, especially on the lower parts of your force main. Obstructions can be an issue. We've all heard of these so-called flushable wipes. These can cause havoc in our systems. We can have partially closed valves. There's many types of obstructions that can take place in our wastewater systems. Air is an important consideration. At our high points on our force mains, we like to put these air relief valves. These air relief valves are notorious if we're not working properly on force mains. And why is that? Well, they tend to get gunked up and again, out of sight, out of mind. They're typically not part of maintenance programs. And eventually, utilities, you may just kind of give up on their air relief valves. Well, think about that air that's in those high points of the force main. That air that's in there is effectively reducing the cross-sectional area of flow. That alone causes more head loss in your system, which can cause lower velocities upstream, which can cause more solid settling. And so you see how some of these things, it's like a snowball effect. Time is an issue. Over time, pipes simply get rougher than when they're brand new. And with that roughness comes higher friction and more head, more pressure on your pumps. So all of these things can be happening in your force main, and you may not even know it. Of course, you know that time is taking place, but a lot of these effects on the force main and subsequently on the pumps are really not looked at closely. In addition to your pump and force main performance, when we're doing these site assessments or pump station audits, it's really important to look at the overall condition of your assets. We have concrete out there. We've got metallic items, such as pipes and panel boxes, and pumps. These things can corrode over time, especially when they're close to wastewater and some of the corrosive effects associated with hydrogen sulfide. So when you go to the site, it's important to look at, is that corrosion really taking place at your pump station? And if so, how bad is it? It can be happening in your wet well. It could be a situation in your wet well in which maybe it's not so bad and your wet well could be lined. Maybe it's an issue where you have imminent structural failure. So it's important to look at the condition of the various parts of your pump station. The site evaluation. First of all, with the site, do you have the proper access? It's really important for the utility folks to be able to access these pump station sites. Again, these sites can tend to be remote. They might have long access driveways. And what happens during storms? Is your site flooding? If not, is your access road flooding, such that you may not be able to get to the site? Your pump station site may not have a permanent generator power there for backup power. You might have to bring that generator power in on trailers and hook up to provide power reliability that way. Well, what happens if you can't get those portable generators to the site? Sometimes when you're looking at these sites and you're questioning, okay, what kind of floods have occurred out here? You may not be able to simply rely on flood maps. This is where the O&M staff come into play again. The simple question, how high have you seen floodwaters at the site? And they can give you some good information that you may not be able to find elsewhere. Are there bypass pumping considerations at the site? How is that performed? Yeah, typically, if there's going to be an issue at the pump station. Does the site drain well? All of these things need to be considered. And while you're out to the pump station site looking at the pumps, these are things that can be looked at as well. Electrical and instrumentation. Do you have reliable power? Is there a permanent generator? Do you have portable generator hookups? When you open these panel boxes, is there spaghetti wiring? Is it something that can be easily worked on if necessary? What about your alarms? Some of these pump stations have auto dialers for alarms. Is that auto dialer system working properly? Are your audible and visual alarms working? Instrumentation. It's important to look at the instrumentation. In a lot of these pump stations, there are floats that are used. Sometimes those floats can get gunked up with grease and so forth. And it's really important to make sure that those floats are working properly. With grease especially, that can pose some big problems with your instrumentation. Arc flash. Is arc flash considered? So these are different things that can be looked at with your electrical and instrumentation systems. Safety and odor assessment. What you see to the right there is a little gas detector that can determine levels of hydrogen sulfide. Why are those levels of hydrogen sulfide important to understand? Well, at certain levels of hydrogen sulfide, you're dealing with a nuisance, just a bad smell. But if that level gets too high, it can be dangerous, especially to O&M staff. As you move further away from pump station sites, of course, the odor gets less and less, and the level of hydrogen sulfide gets less and less. But those individuals that are working on site, if you have high levels of hydrogen sulfide, it can be dangerous for those individuals. Are there risks of falls? Are there exposed moving parts? All of these things really need to be looked at. I've seen some situations where you have operators that go up to the control panel and they might have an open hatch in the wet well right behind them that doesn't have fall protection. That's a safety issue. Confined space is an issue. For a lot of the pump stations out there, confined space is not necessary. But for some of the old pump stations, you might have your little can pump stations and so forth. It does require confined space entry. Some of these smaller utilities and so forth, they might only have one individual that goes out and visits these sites and enters the confined space alone. That's a problem. And so that's what really needs to be looked at with the safety assessment. So once you get all of this information about your pumps, your force mains, the site condition, safety, once you look at all of that at the site, it's time to develop the audit report. In that report, of course, you want to ID all of the problems that you encounter on the site and that you heard from the O&M staff interview. And then you want to develop rehabilitation recommendations. One of the big ones, of course, is your pump operating the way it's supposed to. It could be a pump issue, could be a force main issue, it could be a combination of both. But does your pump need to be replaced? Does the impeller of the pump just need to be replaced? Do you just have the wrong pump in there? Sometimes what happens is utilities replace pumps and they may not replace them with the same pump that was in there previously. With force mains, is it clogged? Can the force main be cleaned through pigging, for instance? Is there structural rehab or replacement that's necessary on site? So it's important to develop those rehab recommendations and then come up with a preliminary cost opinion for those rehab recommendations. Then what we need to do as you can see in that graphic to the right, we need to look at the likelihood of failure versus the consequence of failure. The likelihood of failure is determined based on our overall assessment, what's happening out there. How's the pump performing? And that's all part of your assessment and coming up with that risk or likelihood of failure. With the consequence of failure, what's typically done is looking at mapping and so forth and determining things such as how close is the pump station to a stream or a river? How close is it to a major thoroughfare for roadways? Is it a large pump station that if there's a problem there, it's going to mean big problems? So the bottom line is, if you look to that graphic to the right, if you have a pump station that's at high risk of failure, and there's also a high consequence associated with that failure, then that should be the highest priority that needs to be addressed in the CIP.
Marco, we have a quick question regarding what you presented on the previous slide.
Yes.
Harish is asking, are reduced oxygen levels along with increased H2S hazardous for the O&M staff while working? Is the oxygen level monitored?
The oxygen level is typically not as much of an issue if they're above ground, but if you get into confined spaces, then yes, oxygen levels can be an issue, and so it's important if you're dealing with confined spaces, that you have the proper OSHA training, to have the PPE and so forth, to be able to combat that issue. It's also important if you have a confined space, to have a buddy system in place. So that is a big issue if you're dealing with confined spaces. Fortunately, a lot of the pump stations out there, it's not necessary to enter confined space. In reference to hydrogen sulfide, again, yes, they can be dangerous to O&M staff, but I will say that situation is relatively rare. What I would say to determine that is if you have this little instrument to determine what your levels are, if you're concerned about that, these instruments are really not costly at all. And if you have significant odor at a pump station site, I would say it's important to understand how high that odor is and how high the level of hydrogen sulfide is to determine if it's a dangerous level or not. Typically, once that odorous air gets off site, it's not typically a danger to the general public, but it can be a significant nuisance. I hope that answered the question.
I think it does. Thank you.
You're welcome. Okay. So once we look at the likelihood of failure and consequence of failure, it's important to prioritize the different rehab recommendations that we made. And simply put, these utilities can't take care of all of these problems at the same time. And so we have to spread it out in a capital improvements program. And I'm sure that, as you might imagine, the highest likelihood and consequence is going to be at the top of the list. And the ones that are in green with the low likelihood and low consequence of failure are going to be the ones that are later on in your CIP. This is all put together in a report, but it doesn't stop there. What's really important at that point is the information is presented in a way that the council or board members understand with the utilities. At this point, I'd like to turn it over to Jason McClafferty to talk about 4 case studies of pump station audits.
Thanks, Marco. Hello, everybody. As Marco said, I'm going to go over a few case studies to show how pump stations are initiated. Also talk about the findings that can be uncovered through an audit. The results of any recommendations that come about stemming from that audit, and then any lessons learned that were able to be gathered from the audit experience. So for our first case study, this is a situation where a new development was being proposed that would require capacity at an existing pump station. So the audit was initiated in order to gather data to determine what those upgrades would need to be. At that time, before the audit was performed, the only data that was available were the asset age and pump run times. The pump run times were primarily used to make that determination that upgrades were going to be needed. The pumps were running about 14 hours per day, both pumps that is, which was pretty significant. So the determination was this pump station was out of capacity and upgrades were almost certainly required. The audit was performed for this station, running through many of the steps that Marco just went over. And it turns out through the drawdown testing, it was found that the pumping rate was less than 10% of the design rate, which was very eye-opening. The design flow rate was 300 gallons per minute for this station, and the drawdown results were 30 gallons per minute. It was also found through hydraulic analysis that the force main was clogged, and it was recommended that the force main needed to be cleaned. The collection system was also analyzed to look at the full drainage area and determine what the existing flows are based off the pumping data using the run times and the pumping rate. And it was found that the existing flows that this station that this station was receiving were a lot less than assumed. Next slide, Marco. So the results of this audit, really the big key here is there were significant cost savings that were achieved as a result of this audit. Once the force main was cleaned via pigging, a subsequent drawdown testing was performed, and it was found that the pumping rate was right back up to the design point of 300 gallons per minute. That, coupled with the results of the collection system analysis, revealed that upgrades were no longer needed at this station, or wouldn't be needed at the station at all, counter to what the initial thought was. So the development approval process was also streamlined as a result of this. The upgrades would no longer need to be designed and constructed. There was no cost sharing that would need to be worked out between the utility owner and the developer. So the approval process could run a lot smoother. Also, the performance of this station was greatly improved. The run times were drastically decreased, which would result in saved electrical costs and wear and tear on the pumps and the other mechanical systems for this station. Next slide. For the second case study, this involves new technology being implemented on pump stations. There's a lot of technologies out there that can be utilized for pump stations, from controls and SCADA. There's a lot of new technologies that are continually coming out for pump stations. In this case, the technology were variable frequency drives, or VFDs, that are used to control the motor speed and thereby control the pumping rate for that pump station. In this case, the VFDs were implemented as with the goal or the intent of achieving electrical savings. The VFDs can really be utilized very well to achieve electrical cost savings, but it needs to be done in a planned and thought out process. The reason for the audit and the reason for it to be initiated was because there was frequent force main clogging occurring for the stations where these VFDs were installed. And it was starting to become a real head scratcher of what was going on here. So audits were performed, and it turns out that digging really far into the details to try to come up with the issue here, there was a mistake made in the controls logic for these variable frequency drives. The initial intent was to have the VFDs speed up the pumping rate at least once or twice per day to achieve scouring velocity. It turns out that that was not occurring, and that led to solids deposition in the force mains, and then eventually the clogging issue. So overall, the audit was able to reveal that the goals of the electrical savings were not achieved because of this force main clogging and lost electrical efficiency due to it. It created unnecessary problems because now that force main clogging issue had to be addressed. Luckily, in this case, a lot of the clogging was able to be relieved due to increasing the pumping rate more frequently than once or twice a day to get the scour velocity up in the force main and help self-clean. But there were some issues, some instances of pigging needed to be done to clean out the force mains completely. And overall, there were capital funds wasted in this program that were not able to be recouped due to the lost electrical efficiency. Next slide. So as a result, it was identified that there needed to be proper planning and monitoring in place when this new technology was going to be introduced to these pumping systems. The planning was done actually fairly well. The one key here was that controls logic needed to be ironed out in more detail, making sure that scour velocity was going to be achieved at least once or twice per day. But really, the monitoring is the key here, that it would have been best if routine monitoring was being done to verify that scour velocity was being met. The force main clogging was significantly reduced once the controls logic was worked out. The frequency of force main clogging virtually disappeared once that was worked out. And one of the key lessons learned in this audit was that the standards for technologies really needed to be improved. The technologies and control side of pump stations, a lot of time is glossed over when it comes to standards that are developed for pump stations, especially local standards for smaller municipalities. A lot of that is left up to the design engineer and the operators and maintenance staff. They do not actually have a lot of say of what's going to go into these stations. So it's best if those standards are improved. Next slide. Case study number 3 involves pump stations that have frequent or recurring failures. In this case, the failure was associated with the pumps themselves. This station was a smaller station, but the pumps kept having to be replaced every 2 to 5 years. And at first, there wasn't a lot of thought given to why or what was going on and why these pumps were failing, why they had to be replaced. Because they were smaller, the cost initially was not very high, but over time, as these pumps had to be replaced time and time again, the cost added up, and that's what initiated the audit, was to try to figure out why this was occurring. The pump station was run through its paces. The audit was performed. Everything on site looked great. All the drawdown testing that was performed was fine. There were no imminent issues. So what the audit team had to do is actually go back and start digging through a lot of the design data and really try to figure out what was going on here. It turns out that the pumps weren't ideally suited for this situation. On paper, everything looked great. Everything looked like it should be performing as well as it should be. But when we did a detailed hydraulic analysis on this station, we found that the pumps were operating far, far to the right on the curve. There was a slight change in a head, similar to what Marco talked about previously, that really threw off where the operating point was on these pump curves. So the audit found that it's best to switch pumps here and utilize a better suited pump that can deal with the varying head conditions and is not going to lead to these pump motors burning up in this situation. Next slide. So as a result, we learned that the original design is not always correct. We can't always assume that because that pump went through that design, went through the permitting and construction phases, it's not always the right decision to make to just replace in kind or replace what was already there. Especially this is the case if that component is failing frequently or not living its full lifespan or expected lifespan. Recurring failures definitely should be investigated. It's understood that components are going to fail, and this happens time and time again on pump stations. However, if there is a component that is not meeting its life expectancy or having to be replaced more frequently than you think is necessary, we really should dig into the details so that we don't have to keep spending this money and time on that component. And we also learned that small problems really can blow up into something bigger. We keep it out of sight and out of mind. They can be a very small cost in the beginning, but over time, as these problems continue to occur, the dollar amount in total at the end of the day can be pretty large, and can really make decision makers wonder, why are we doing our operations this way? Maybe we need to get out ahead of these small problems rather than wait for them to balloon. Next slide. So for the fourth and last case study for today, we're going to talk about a station that, in my mind, I like to call this the complete station failure. Basically, this station suffered from start to end, from planning all the way through to the operation and maintenance stages of this pump station. The audit was initiated because this station was frequently clogging. There was significant wet well surcharging to the point that the owner was worried of an SSO occurring at this station, which was right next to protected wetlands. So it was a scary situation that needed to be addressed. An audit was performed and found issues basically every step of the way. One of the biggest alarming issues that was found is the incorrect pump and piping were installed in this pump station. I actually was on site for this audit. We opened up the wet well, and when we saw the piping in here in the wet well, which was 1.5 inch PVC piping, and we were expecting 3-inch ductile iron piping, it was very eye-opening, and alarm bells started ringing off in everybody's heads. We found that the original design was not suitable. One of the issues that this station was facing is the wastewater stream coming to the station was primarily from schools, and there was a lot of debris, things like mop heads coming down the gravity sewer line that the station was not suitable to handle. And there were significant changes made during construction that we were able to find through documentation. And there wasn't a lot of reason behind it, or it doesn't seem like there was a lot of analysis behind these changes to have them deviate from the original design. So at the end of the day, the recommendation ended up being for this pump station that all of the guts of the station had to be replaced, unfortunately. All the piping and valves, the pumps themselves, so that we had a suitable pump selection in here. And one of the other recommendations was to install a trash basket to deal with the debris that this pumping station was not going to be able to handle itself. Next slide. So again, that recommendation led to the full replacement of those components. Overall, the performance of that station increased dramatically. To date, I'm not aware of any issues of any pump failures or any significant surcharging at that station once the recommendations were put into place and implemented. So overall, the station performance now has been greatly improved. That's led to a lot of reduced operation and maintenance and costs that the owner was having to incur because of this problem. One of the key lessons learned here, and something that really opened up our eyes when we performed this audit, was that there's so many different opportunities for problems and also solutions to arise when it comes to pumping systems. It's really important to make sure that planning is done properly for a pumping system, making sure you understand the waste stream that's going to be coming to that pump station. The design needs to take this into account as well. The construction needs to be done in accordance with the design documents, or at least have the appropriate folks available, the engineer, the operations staff, and really get those folks involved in any key decisions that need to be made during construction, especially for any changes. And then, of course, during the operation and maintenance of the station. One of the eye-opening things that I've realized through audits is that the operations staff largely is left out of the equation when it comes to the first three: the planning, design, and construction of pumping systems. They're key stakeholders for these pump stations, and it's best to get those folks involved through every stage of a pumping system from start to finish, to make sure that they're aware of what they're going to end up owning and maintaining. So that concludes the case study portion of the presentation. I'm going to hand it back over to Marco, who's going to wrap up with some conclusions.
Thank you, Jason. Excellent case studies. And as he said, I'm going to wrap it up with conclusions now. So we hope that we've stressed the real need for pump station audits. Really what it comes down to is, are you being proactive as opposed to reactive? Being reactive to problems in your wastewater systems and your pump stations can be more costly, can cause public health issues or nuisances, and can cause environmental problems through SSOs. So in these audits, we want to focus on the right things in the right ways. We want to be as comprehensive as we can, but we also want to scale it back if necessary, due to some funding challenges. We want to present the information in a clear manner, not only with the report, but in the presentation to the council or board. And again, this really comes down to the triple bottom line. These audits can provide triple bottom line solutions: reduce or eliminate public health and nuisance, reduce impacts of SSOs, and ultimately save money as well. That concludes our presentation. And I think we have a little bit of time for questions.
All right, if you have any questions, you can submit it in the Q&A. You can see the button at the bottom of your screen, or you could actually type it in the chat as well. We'll wait a minute to see if anybody's got any questions. All right, we have one from Carrie. The question is, how often should SPS audits be performed?
That's a great question. And these pump station audits, you typically, when they're performed, it's the first time that they're performed. But I would say that a comprehensive audit, if it's performed every 5 years or so, that would be enough. These pump station audits don't only need to be performed by engineers. O&M staff can be trained to do a lot of these pump station audits. You really more on a continual basis. I recommend that as part of the preventive maintenance program, that O&M staff be trained to do some level of these audits on an annual basis.
Marco, we have one more question. This one's from Daniel. Daniel is asking if there is any AWWA standard used to guide what's done or checked during the audit.
I'm not familiar with any AWWA standard as far as audits are concerned. These standards that we've developed, and engineers have developed, are really just they come from just engineering principles and understanding how pumps operate. Jason and I are both trained in understanding condition assessment, and so once if you're trained to do that, as many are, then you can go in and understand, okay, what's the condition of the material here? Is it something that needs to be rehabbed or replaced? Really just a lot of the engineering principles that are developed over time, that we tend to focus on. So no, I don't think that AWWA has specific standards for these assessments.
Very good. Another question from Anthony. The question is, what is the basic procedure for a drawdown and what does it tell you? So
the basic procedure with a drawdown test is, these pump stations, whether you typically have three types of pump stations. There are more types of pump stations, but the bulk of the pump stations out there, I would say, are either submersible pump stations, wet pit, dry pit pump stations, or they're suction lift. With each one of those, of course, there's a wet well. That the wastewater is stored, and as that wastewater rises up in the wet well, it gets to a certain level where the instruments will tell the pumps to turn on. And then once the pumps turn on, there's a certain level closer to the bottom of the wet well where the pumps will turn off automatically. There's an operating range in there. But these pumps can also, control panel, they can typically be hand operated, so they don't respond to those instruments. And so when we perform these pump station drawdown tests, we like to turn those the controls to the hand operation as opposed to auto. And then we can simply ask the operator to turn on the pump at a certain time, and then we have a clock that measures it tells us how much time has gone by, and typically a time frame of about 5 minutes is okay, or maybe it's less than that. Then we measure how far down that wet well goes in water level, and be done. It could be very rudimentary, with a tape measure, or you could actually have an instrument that measures the level drop. And so if you have that time frame and that level drop, then that typically gives you the information you need. But you also have to consider what's coming into the wet well during that time period. And so you can do things such as monitor the flow with instruments in the gravity sewer piping coming in to the lift station, or prior to that pump drawdown where you actually turn on the pump, you can measure the rise in the wet well over a period of time. That can give you a pretty good indication, with a little bit of error range, how much flow is coming into that wet well. To really determine what that flow is, both the incoming and outgoing flow, you simply use the geometry of the wet well. Most of these, or a lot of these wet wells are circular, and so you simply use the geometry. We know that if it's going up or down a certain distance, that represents a certain volume. So that's really how we conduct the drawdown tests. I hope that answered the question.
I think that our last question before we wrap it up is from James. James is asking how the SCADA system can be integrated into an ongoing audit process.
Yeah, so with an ongoing audit process, you can have a really robust SCADA system, where you have folks just sitting at a computer, really understand what that the flow is every single day, instantaneously at pump stations. Or you can simply kind of the lowest level is to go out and measure the run times of your pumps. And so if you install a pump, for instance, and you have run times that are increasing, it might be a pump that's been there for 5 years, and your run times, you might see that they're increasing, but there's you didn't anticipate there was more wastewater coming into your pump station. That could be an issue. That runtime might be increasing because you have a clog in your force main. And so even if you don't have a robust SCADA system, there are things that you can do to understand how your pump system and force main system are performing.
With that, I'm going to go ahead and wrap it up. Thank you all for attending today's session.